Yo, 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 good morning. So let's continue with this re-implementation and improvement of the fluid solver. I don't know for how long I will stream today, not feeling 100%, but let's give it a try. So we have this data and we store it in textures, and now I want to be able to swap channels basically. So if this one is stored in the red channel and this one is stored in the green channel, I want to be able to switch those two. And I wanted to make it generic, so we probably, the way we're going to use it is water temporary. These three are going to switch around a bit. So I would like to implement it like this right here, I think. So we just say one data type and another one. Like, let's see here, if we knew which types there were, we could do something like okay, so if we knew exactly which channels we want to swap, and we knew that they both were in the same texture, then we could probably just do data array is equal to 2, and then we do so for instance, if you wanted to switch G and R, but it's not gonna be that easy. I wonder, when we do the swap data blit here, we differentiate. I wonder if we want to do it here as well. Wonder if it's that important. Let's see, we're gonna do, I think we can do like this. It might not be very quick, But let's see here. Now we're going to do it like this. Let's set. So I think we're gonna do this. Let's see. Type 1 data array I is equal to type 1 dot set Yo, what's up, I'm me. Are you thinking about how your shaders will work on shit class GPUs like the Switch? No, not yet. Anything special to keep in mind? Or anything specific you're thinking about? Let's see, type 1 set value. I think we're going to do type 2 data array I type 2 channel index. Old values. Yo, good morning, Wesley. I'm me lots. Feel free to specify. Type 1 data array, type 1 set, type 2 data array. The fuck? Old values. Do we just go with temp? Yeah. Okay, let's see. Is this actually how we want to do it? Save tape 1 data, and then type 1. Ah. I don't know about... I mean, low-level Perspirive means overlap on GPU tiling hardware. Have you tried to run it on a switch, for example? High-level GPU hardware is not the same as low-level hardware. Yeah, that I know. I don't even know if I'm gonna release it on a switch. We're a bit far from that. Let's see here, what a mess this is. That's the value we want, that's the old value. So I think it might be correct. I'm gonna test it. And I'm gonna test it by just doing... We're gonna test it by just doing a swap here, I think. But I think we're gonna have to do it in terrain base, because we're gonna have to do it on all terrain patches. I'm me. What do you think will happen when you're to adjust all your shaders, etc., to realistic targets? I think they are pretty realistic so far. But then I will just have to adjust them. I'm not sure what you're getting at. For now, I'm yeah, we'll probably just add a method around here, I think. What do we have? Generate. Yeah. Feels a bit unclean. Me, what you're doing isn't going to work on PS5 or Xbox. Probably. Yeah, I'm anticipating I might have to do some changes. But you could probably make it work on PS5 or Xbox. I don't see why not. So basically what we want to do is we want to switch two data around. Fuck, it's gonna be slow as hell. I wonder. But I think we're also gonna have to do this if we want to add some cool. Although, one sec. I'm wondering if this is actually the best way around it. Water, previous, water, temporary. We could probably do this in a nicer way. Instead of switching these during the algorithm, we could just we could just tell the shaders which channel is which instead of switching between them. That's probably a better way to do it, but for now we're gonna do it like this. Let's see here. But So instead, when we're doing the fluid solver, or what I'm getting at is that we could rely on terrain data type increment. So when we start the fluid, so let's see here, terrain data 2, or the second texture of terrain data, has water related data in the RGB channel. Which one of these that has the data we change each time? So let's say that we have water amount in R. So the next time we go through the algorithm, then G is water temporary, B is water, or actually the next time we do the algorithm, one sec. The next time we do, okay, let's see that we have our water data in R, and then we prompt a fluid solver iteration. Then R becomes water previous, G becomes water temporary, and B becomes water. And then we just move them like that every time. So the which channel is which is changed between iterations of the fluid solver, and we just tell the shader which is which. Might be way quicker. Have you tried running your game on an iPhone or iPad recent? Are we talking about this game? Because this game is not going to be playable on iPhone or iPad. I did, however, develop some games for iPhones and iPads in the past. Why are you wondering? Oh, back. So you're aiming for 10 years from now, or whatever PC is current. I still don't know what you're getting at, man. Like, first of all, I'm sitting on 10 years old hardware right now, pretty much. And when I develop my custom shaders, and I use non-standard functionality or methods, I take a note on like for which OpenGL version or HLSL version it's available. What's the good of it? What do you mean? What's the good of it? Yeah, so switching these channels as we go, or incrementing them, is probably the best way to go. Might be better to let's see here. We're actually going to put this in. Okay, I just want to see if this works before we continue. Okay, so after this iteration we have water in water temporary, and let's change water temporary, and let's see if this works. And beautiful. It's quite slow, but it's okay. Okay, nice. Now we have this method to rely on. That's very nice. So algorithm step 2. I've been down this path. Yeah, like so have I. Like this is not news to me. But I still think we're pretty far off from testing it on actual hardware right now. I want to make it work first, right? Okay, so step 2, calculate non-overflow fluid amount per minima. So we want to do this first. We want to order them. I'm still not entirely sure exactly what we want to order them by. But I think we're gonna do this. Let's see here. Algorithm step 2. pretty sure we want to order them by descending, just like this one, I think. Once again, depends on the costs of walking, though. Final point. Order by descending. Second while loop, but this one will have multiple while loops in it as well, I think. Calculate invalid end nodes. I don't know about that. Oh yeah. So pretty much, given a minima and its fluid amount, we want to find... I wonder... We can probably make this a bit faster by keeping a reference to visited nodes, highest point, I wonder if maybe I want to make some changes to this one here, but yeah, maybe we should start by just cleaning this one up. So basically what we have is a set of minimas with a fluid amount, and we want to see if this minima will be able to hold some fluid. And how much. Given this, I think. What do we do with highest point? Highest point is P. Yeah, I think these two specifically is where we can do some nice changes, definitely. We cut the most fat. But then again, invalid endnodes, yeah, we don't need this list. Pretty sure. Okay, so we spread it. We spread the fluid. If we find a point where we can't add fluid, then we check if if we want to check if we can't add it because it won't be able to spread. Because, okay, I guess, yeah, this one could return false if we do get some fluid spread, but a lesser amount than currently in the neighbor point. But yeah, okay, so if we can't spread because the water can't move any more steps, then we calculate, we actually check these as well. Yeah, if the heights are the same, well, oh yeah, we also want to check this. Okay. Okay, so what would be the difference between this case and this one? Okay, so the first step here, this is the same as we previously did, and we just want to be able to handle these two. It's very important that we get these correct. Then we calculate the phone. Okay. Okay. Which terrain data type we're working with as well is very important, or which water type. Previously we had finding minimus fluid, building graphs fluid. Did we have a third as well? Yeah, fluid amount. Yeah, I'm wondering if we want to do something like this before we continue. Water temporary. So if we check at the old implementation, if we have finding minimum fluid amount, after we have ordered them by descending like this, we do add buildings graphs flu. We move that one to add building graphs. Is this I wonder how important it is that this one is zeroed, so to say. Add buildings graphs fluid. Like what I'm getting at is, should we maybe just override it? It all depends on if we're revisiting nodes or not. Which I don't think we should. Thanks to this one. Ooh. This might be the case for some revisiting I saw that shouldn't happen. Interesting. Extremely interesting. Fuck, I want to retry that. Let's see. So mono behavior. Okay, we did it like this. Why not? Minima threshold fill byte, yeah. So in the old implementation, in step 2.1, I think we had a revisiting issue, and that's because of the order here. So when we reorder unvisited nodes, we do it on finding minima's fluid amount, but it's actually on, pretty sure it's on building graph's fluid amount we should do it. I think the end result will be the same. It's just we will reach the end result way faster. I think. So I just want to do a quick test here. Let's see here. What if we add one here? Fuck, we're probably gonna get... Okay. Pretty much the same, I would say. pretty much the same. I'm gonna see if we can do without this one. Instead, we're just gonna go with lowest unreachable height. I think this one should be enough. And if we fail, Wesley, at least we see some water now. Yeah, that's true. Fuck, I'm still worried about... I'm still having second thoughts about these checks here. We should not have to do these checks. I'm pretty fucking sure. Or... let's see here. If neighbor has been added to unvisited nodes, well, let's see here. We always move in the direction where we have the most fluid. I want to check. I want to double check it. Yeah, I just want to see if this happens. And if it happens, I wonder if I should be able to eliminate the cases where it's done. Yeah, okay, beautiful. I'm pretty sure this is the case. This is very nice. What's there? I'm pretty sure this is the case here. And it's the case here. The thing is, it also depends on the costs we have, but it should be okay. Yo, what's up, Derek? Okay, but this is very good to know. So. Okay, we don't have to worry about that. Beautiful. highest point, lowest unreachable height. I think, let's see here. Highest point, lowest unreachable height. Do I need both of these? Invalid end nodes. I'm pretty sure we should be able to combine invalid end nodes, highest point, and lowest unreachable height. What it all comes down to is we want to figure out how this fluid spreads. If let's see. Or what we're doing here is so if the fluid spreads and it stops spreading, and it stops spreading because of running out of water, or if it stops spreading because of it has to move upwards in all directions. Yeah, that's pretty much what we're figuring out here. But we're figuring it out in a very dirty way, I would say. Yo, what's up, Redstone? Highest point. my roof last time I checked. What do you mean by that? Yeah, so first of all, I'm just trying to make it makes sense, but okay, Redstone, yeah. Sorry, I'm a little bit slow today. Wouldn't ceiling be the more correct answer to that joke? I'm just wondering. Invalid endnodes here, the way it's implemented is fucked. So as soon as we find an invalid endnode, we break the for each. So we jump down to this. Although it might not. No, because then we add more. Fucking hell. Never mind. We break and unvisited nodes clear. So this one is false. So yes, we don't even need we don't need this list. We could instead just set final fluid amount here and break. That's what we could be doing. The sky would be better as that's the goal, final goal. I guess. Or it's universally true, I guess. Unless you ask someone on ISS. Okay, so that's this one fixed. So this one we can simplify a lot. Let's see, what do we use here? We used highest point and lowest unreachable height. Let's see, highest point is set here. So at every point we visit, we check if it's the highest point. If so, we do something. This one we might have to introduce some additional stuff, unless now I think we can do these calculations within here, so we don't even have to do this in the end. Final fluid amount, we calculate final fluid amount here, we calculate final fluid amount here. If it's less than 0, we break. Lowest unreachable height. So lowest unreachable height. This one helps us find, so like if we disperse the fluid in such a way that it dries up when it's moving in parallel, that's when we get lowest unreachable height. Depending on cost once again, but with the default costs we have, that's the case. Highest point is, yeah, the highest point we traverse. Actually, how I see it, fuck, I think I wanna clean this one up here before we optimize it. If we're always moving in the most amount of fluid, if we get to a point, if this one fails, because we're moving upwards, then we continue with the loop. But if this one fails for any reason, because the fluid dries, if this one fails thanks to us moving in parallel, then we just exit. So much like we exit early here, I think we should exit early here as well. Why don't we? So for us to get here, we're not able to add fluid. No, actually. Yeah, this one is... This is for us moving upwards and not being able to add fluid because of moving upwards, right? So then we want to continue. Lowest unreachable height. I think it's pretty straightforward. It's just this implementation is weird, or not the cleanest. Traverse fluid. If we dry up, i.e. we're moving in parallel and we can't move any more, then we have found a invalid end node. We need the value, the height we have of this one, because that's how much fluid we want to add. Otherwise, if we reach a point where we can't move because we're moving upwards, we do something else. Okay. Okay. So I wonder... Yeah, I think we can do this. Clean it up a bit. I'm gonna wait with introducing these ones again. And we're just gonna do... Okay, so next big question, which I've visited multiple times, is terrain data type. What do we want to use here? When we start the iteration, we have something in water, and we want to move that one to water previous. We fill water temporary first. So when we're done with the first iteration, I think that we probably... We don't need this data anymore. So I wonder... if... So when we start the iteration, or when we start the fluid solver, we move whatever we have here into this one. We fill this one up during the first iteration. Then we probably want to take this one and add it here. Or swap this one. Not swap, but we want to take what we have in here and put it in here. But we also want to alter it a bit if we want to animate it in a nice way. So we would probably take... We take whatever we have here. Bring them down to a small amount. Add it to this one, unless this one is bigger than we add this one to this one. Yeah, that's a mess. But it's much like... So when we do the first step of the algorithm, that's basically where the fluid solver finds the minimas. That will the related minimas. If we want to animate this in a nice way with the water, I would say we add a small amount of water so it looks that water is flowing to the minimas. I think it might be doable. It's extremely hard to explain right now, but yeah, I think that's the way we're gonna do. Take water, move to water previous, do the first iteration of this one. When that one is done, take whatever we have here and put it in here using this one. And then when we start the second iteration, we fill this one up again. And then when we're done with the final, or with the second iteration, and we're doing the last iteration, then we just fill this one up, I think. And we can leave this one as is. I just wish that we had a nicer way of swapping the channels or working with channel swaps than this. But basically what we want to do is, I want to do some more, add fluid, stopwatch restart, and then first of all we do prep. So swap though, yeah, we're gonna have to implement some swap data channels, replace data channels, swap. So we probably want a function like terrain data container swap data blit public void move data. Source destination. Reset source. destination dot set destination set this value, old values, I think, and then if we set source, then we do source data array I I'm starting to think could probably, if we can do some overloads or something like this, make this a bit clearer. Like the whole cause for this is that we're working with color32 structs, so we can't just change one value, or that will recreate the whole struct basically, or we need to recreate the whole struct, and that's why we need to do stuff like this. So basically, if we take a look at this one, all it does is it creates a new color32 based on the terrain data type. Yeah, it's a mess. Which makes one wonder if like when we're rendering this, we're always gonna need the latest data in the textures, so we do need to change the textures on the go. Terrain data container, move data from source to destination, reset source. Starting to think that going that going a single channel texture array might be a better option. Using an array of single probably. Okay, so move data. Move data channels, move data channel, move data. Terrain move data, water to water temporary. That's not what we want to do. We want to move it from water to water previous. Prep. So first step, move water to water previous and reset it then. And then we do water temporary, we add fluid amount. step 2. Yo, what's up, DevSpiers? Thank you, appreciate it. Have a good one. Algorithm step 2. I wonder... when we take the time here... we're probably gonna do it like this. Algorithm step 0. We're gonna do it like this. Finish step. Step description. I think we're gonna do step description. Terrain data type. Pretty much I just want to bake these, this, and these into a method so we can clean it up a bit. Actually, let's keep it like this. Finish step, prep. Yo, what's up, Smack? GD. How are you doing today? Finish step 1, find minimus. Yeah, and we do it like this. I don't know. I'm not entirely sure, like, what speed. Like, of course I want this one to go, to iterate as quickly as possible. But I don't know which speed, or like how much time would be my worst case, but still acceptable duration here. You can probably, like, adding water in the terrain, it's not something the player is gonna do a lot. So we have a little bit more lenience on how slow it can be. But let's see, like hiding, I don't know, 2 seconds of computations behind an animation for this use case would probably still be okay. 2 seconds. 2 seconds, yeah. Worst case would probably be like 5 seconds. If it takes longer than 5 seconds, we're fucked. Neruns, by the way, thank you for the follow, appreciate it. And right now, like this, I've said it previously, but like this might possibly change. But I'm thinking, so adding water to an area, the player instantiates it, the character takes up the tool or whatever that adds water, and then starts playing the add water animation. And during that animation, the water will rise, but it will rise in steps. So maybe the water will rise 0.1, and then we will have another iteration of the algorithm. Then it will raise 0.1 more, then we will have another iteration of the solver, and so on. And the player will be able to cancel it at any time. 2 seconds would be nice. If we get 2 seconds on a first iteration, that pretty much gives us the option to add even more data, or actually maybe even generate stuff. Yeah, we'll see. Finish step 1, find minimus. Then we do step 2. Yeah. Oh yeah, before we do step, actually we're gonna do this. Step 0 or step 1 prep. And then we have step 1 find minimus, and then I want to add, because we want to move data here as well, and this might be quite costly, but let's see here. We want to move data. We don't only want to move data, we actually want to compute some new data as well. So we want to move water temporary into water. But we want to do it in a certain way. And move data water to water previous. I think this will be one of those cases where we doesn't reset the source. And here I want to do a very specific thing. So move data, I pretty much want to do this. Let's see here, water previous, no, not water previous, but water temporary to water. But I also want to do, so this one we want to clamp. We want to clamp it between 0 and 0.1, I think. We want to take the result of that and add it to this one. So move data. We can probably if once again the way we're storing this data is screwing things up, I would say. If it were just plain integers, we could do alter data, source destination, and we could send in a lambda. But yeah. Yeah, one thing. We could go with alter data and still have a lambda, I suppose. that will look. Move data, swap data. Then I wonder, attribute, is it this we want to do? So would it be action what do I want to return here? Byte maybe? Maybe keep it easy, clean instead. Or, let's see here. I guess we could do... Let's see here. Okay, let's start by doing this. Alter data. Destination set, and here we do alter instead. Source data, destination. So new value, we have old values plus sign times value, yes. Okay. So alter and put in destination, reset if we should. Okay. Okay, this is good, but I would like to have the option to change this value. Before we add it. Laran, thank you for the follow, appreciate it. Yeah, going with an action here might be the best option. What do I want to call it? Something like that, I think. Yeah. That's it. Wait, do I actually have game.action? Ooh, one sec. Is it actually func we want? What I want to do is source data array I source dot channel index, something like this. And then we do alter value here. I wonder. So pretty much a method for altering data. We want to alter destination data. We want to alter it by using source. And we have a source data transform as well. And we have the option to reset source when we're done. We calculate alter value by getting the source value, transforming it using source data transform, and then we set destination data by altering the current value. So let's see, how would that look in... Yeah, then of course we need this extra step, which I hate, but what did I call it? Source So finally it would look something like finish step 1, find minimas, environment control terrain, alter data, and we would do something like clamp S between 0 and what can we do? 0.1 to 55. Is that what I want to do? What is the correct syntax? Oh yeah, we send in 2 here. It's void func float. Alter data, water temporary, water is on S. It's a bit of a mess. Altered data. The naming of this one pretty much suggests that we want to alter this one. But okay. Yeah, one problem here. Here we order final points by descending, and we do it by water temporary. So we want to do this before we alter terrain, definitely. So we're gonna move. Let's see here. We're gonna take this one. And we're gonna put this one here. So we order them by water temporary. Then we reset water temporary. And then I also want to add this finish step 2 prep. Also, finish step 1 find minimas. We want to visualize this one, and we want to visualize water temporary. Yeah, I want to try this before we continue. But let's add finish step 2 finding non overflow amount per minima. Okay, I want to try this. I just want to see what kind of result we get. I'm a little bit worried about this one. But yeah, let's do it. Or 1 sec, I think. Or 1 sec. I think we need to change terrain patch, old solution, new solution. Okay. Water, let's add 0.6 here. And let's see what happens. What do we have? We have water 0.3. Yeah, we're not really... Oh, actually, 25. Oops. Water 50, water previous 25. I think it's working. Let me just see. 0.1 times 255, 25.5. Yeah, we're just casting it, so it should be 25, right? And we should be getting 25 no matter... The reason we have 50 here now is because we had 25 previously, and we added 25 more. I wonder if that's the correct way I want to do it. Okay, so let's add 1 here. We get this. And what do we have? Water 25. Yeah, it works. Water temporary gets reset. Beautiful. I want to double check. Step 1 preps 0.0. What is it? This is extremely quick, actually. I'm quite shocked of how quick it is. Yo, what's up, K-Rain? Welcome. So when I see... So if we go to terrain fluid solver step 1 prep, this one actually involves moving the water data to water previous, and then setting one data element, creating 2 lists. This step, I assumed that this step would take much longer, but I don't know, what is it? 22 milliseconds, is that what I'm seeing? 100... No, 2 milliseconds. Finding minima slow, we're at 0.39 seconds. Terrain fluid solver step 2 prep. 4 milliseconds. And step 2 prep is sorting this one. That one is quick this time around because we only have 1 element. But then altering data. So pretty much a move data, but with some alterations as well. That's pretty damn good. But this one right here, I don't think this is the one I want to do. Not really. Water 25, so what if we add more here again? Water 50, water previous 25. Add again, water 75, water previous 50. That's beautiful. That's beautiful. But yeah, okay, so clamping it between 0 and 25 and then adding it's probably not what I want to do. Eventually we want to do clamp it. We want to clamp it. Yeah, we probably want to make it a bit more complicated yet. Terrain data container, altered data. Source destination, source transform func. Stevie, thank you for the follow, appreciate it. It all comes down to like how generic do I want this altered data function or method call to be, and yeah, I think I want to do it like this. Yeah. So we have a source transform func, and then we have a int alter func. Maybe it's cleaner to have it like this. So source value, destination value is equal to alter func, source value destination data array I, and then we have channel, so destination dot channel index. So source value, we get the source value, transform it, then we calculate a new destination value. We're probably gonna name this one new destination value. And here we send in source value, which has been transformed, and we send in the destination, the current destination value. Calculate this. And then we don't want to do alter here, we want to do set new destination value. Cannot convert from int to byte, that is true. Yo, what's up Nighton? If you want to do something fast, do it slowly. I guess there's some truth to that. Cannot convert from int to byte. Thought we had a set with int. Public static color32 set type int value color32 old values. Type return type dot set, and here we want to cast the value to a byte, but we also want to make sure that we don't overflow or underflow. So byte clamp value between 0 to 55 old values. Fuck. If we have these two set methods, one that takes a value and one that takes an int and one that takes a byte, this one is going to default to int unless... Fuck, I've never done this. I wonder how... Can we do this or something like that? So instead of doing this, we do this. Let's see. Okay, Rain, I don't understand anything I'm looking at. Interesting though. I appreciate it. So, what is it? C# define byte literal, no, uint, this one is for byte, although not really related. Binary format, okay. uint C#. Oh yeah, a bit too big. But fuck, can we do system.byte 0? Guess we could do set int just to differentiate between them. Just to make sure that this one doesn't use the integer method. source transform func alter func. So once again back to this one. Now we can do this. We want to have two functions. Alter data we have int. So what do we want to have? We want to have source and we want to have destination. And we want to return something. In this case, I want to return int the max between S and destination. And here I don't want to return clamp, I want to return if S is bigger than 0, return 0.1 f times. Or actually, let's just return 25, otherwise 0. So source alteration is, if it's bigger than 0, we set it to 25, otherwise 0. And then the alter function is we take the maximum value between source and destination. Let's try it. So what do we have? Water is water previous, water temporary, and timestamp is all 0. And then we add water and we add 1 here. What do we have? Now we have water 25 for all of these. Even for this one, this is beautiful. How can I okay, so if we add here again, we still have water 25. We have water previous 25 as well. Good. Prep, still good times. This one is extremely slow though. I don't know if we could possibly improve it. It's 36 milliseconds. I just wonder. This one we can... Yeah. This one is probably way slower than just doing this. Definitely. Fuck it, let's try it before I quit. The only thing I'm afraid of is that we might end up with an endless loop, but if that's the case, that's the note I'm gonna end on. It shouldn't really happen though. Okay, that's great. Not that big of a difference. That's just one test. I think we can make this way quicker as well. I have to think about it. But yeah, that's gonna be it for today. I was hoping to stream a little bit longer today, but I'm feeling quite sick, to be frank with you. So we're gonna call it. We'll try to stream tomorrow as well, continue this shit show. Thank you so much for watching, everybody, and have a great rest of the day. Peace.